Hello, this is a video for database assignment 2. I will begin with creating a database. Um, let's call it assignment 2. Hmm. Now I will jump to my Java code because I have used this programming language not only for populating the table, but also for creating the table. Uh, I will need to slightly modify my code. And in execute database tasks, I will have only create table methods. Now, after running this query, I will check that I have this table in Postgres. And let's view it. Okay, we have empty table now. Um, Now let's execute another task, another method, which will be insert 500,000 times. Which this uh, this method unfortunately will take some time. So the process finished with exit code 0. So now we can go to pgadmin and check what we have in our table now. And here we have 500,000 entities with randomly generated text1, text2, and number 1, number 2. I also would like to briefly show how it's done. For generate random number, it's simple random class used in Java, which generates random number from 0 to 1 million. And for generating random strings, we can use random class in Java. Now we also generate not only the random string, but also the random length of the string. So we will have first length, which is created randomly and can be from 2 to 30. And we also have this string, alphanumeric string, which we will use for generating strings. So Java will generate a random number, and we will find the character from this string using this number. Now let's test the performance of our table without any indexes. In order to do that, I will open the query tool, and my query will be explain analyze. Select all from table name is random, where number 1 is equal to, for example, this number. I hope that we have some entity with this value as number 1. Let's run it. Yes, we have some entity. So as we can see here, the execution time was 47.3 milliseconds, and Postgres used sequential scan for this query, which means that it doesn't have any better option to run this query, and this we don't have any better option because we haven't created the indexes yet. But if we'll change number 1 to the ID attribute, we will see that it was way faster, and the execution time now is 0.1 milliseconds. The reason is because by default, many databases are using indexes for our primary key, for our ID. And also here, so we can see that Postgres used index scan instead of basic sequential scan. I also would like to mention that after first run, on the second run, our execution time will be lower because the Postgres will save the result in the cache and we'll just get it from here. So run it first time, 60 milliseconds, run second time, it will be 23, 28, 23, 22, and so on. However, this is not the best result we can achieve. And in order to increase our performance further, we will use the hash index. So let's create a hash index here and check the performance now. So now execution time will be 0.2 milliseconds. And also we can change our number to any other number we want. And it's really faster, 0.9, 0.1 milliseconds. So previously I actually made a mistake that all of the dates were the same. Now I solved this issue, deleted all of the entities from this table, generated 500,000 entities again, but now the date field is generated randomly, and the interval is, I choose an interval from January 1st, 2000 till today. So yes, now we're using this method, and the date field is generated randomly, and also I can show that here the date field also are randomly generated. We already tried using hash indexing for our number one attribute. Now let's try to use it for text one and date field also. Created hash indexing for text one. Let's try to search for something. The execution time is 0.1 milliseconds. If we will drop our index, we'll see that execution time now is 29 milliseconds. Let's also create indexing for the hash index already exists. Oh, I hope I have it most probably. Okay, yes, I have created it again. Date field. Let's try date. Execution time is 0.2 milliseconds, and if I will drop it, execution time is 25 milliseconds, or another value, and okay, it's 24 milliseconds. By doing this, we understood that hash indexing really helps us in terms of performance. Now, after I dropped all of the hash indexes we had, now I will create B3 indexing and check how it will affect the performance. So let's create B3 indexing for text one. Oops. The execution time is 0.2 milliseconds, and we can see that Postgres is using our B3 indexing. Let's drop it. Try the same query again. 26 milliseconds, and now Postgres is using sequential scan. Let's try something. Number one is equal to Postgres is using sequential scan, and execution time is 21 milliseconds. If we will create B3, it will drop to 0.08 milliseconds, and it's using B3. And date field. Let's first try without indexing, it is 36 milliseconds. And if we will create B3 indexing, we will have execution time of 0.2 milliseconds. So results were following. In most of the cases, hash3 was faster. The only attribute when B3 performed better was number one attribute. In text one and date field attributes, hash3 performed better. So I would like also to talk about to brief a brief description of B3 and hash indexing, as well as show a case when B3 will be better or hash3 will be better to use. So B3 indexing is faster for range queries and ordered data retrieval, as it maintains a sorted structure. A hash indexing, on the other hand, excels in equality lookups, meaning it's faster when you need to search for exact matches. So now let's try some queries. Okay, so I have it here. First, I will create B3 indexing. Sorry, I created the wrong B3 indexing. Yes. The execution time is 0.041 milliseconds. If we will drop our B3 indexing and create hash indexing instead. Oops. We will see that Postgres didn't even try to use our hash indexing because the performance doesn't improve here with hash indexing. So with the Postgres use basic sequential scan, and the execution time is 24.9 milliseconds. Even if we will remove our hash indexing, we will see similar results here. So now we can also cover text one. So here, first let's create hash indexing. Yep, the Postgres used our hash indexing and the execution time is very low, it's 0.074 milliseconds. If we will remove our hash indexing and create B3 indexing instead, we will have, okay, let's also change did we drop it? Okay. We will see that the result is 0.271 milliseconds, which is, of course, faster if we don't have any indexing, but it's not as fast as hash indexing, because hash indexing is better for equality lookups. So that's it. Thank you.